So back in the summer of 2023, the entire scientific world just got completely electrified. And it was all because of this one claim coming out of South Korea. They talked about a material, they called it LK-99, and it promised to change, well, basically everything. But the big question was it for real? Today, we're going to dive into that global detective story and see what happened.
I mean, just think about it for a second. What if we found a single magic bullet for technology? You know, one discovery that could just unlock a whole new revolution. It's the kind of thing scientists dream about, and for this one brief, exciting moment in 2023, it really felt like it might actually be happening.
So for more than 100 years, scientists have been on this quest for what they call the holy grail of material science, a room temperature superconductor. Now what is that? It's a material where electricity can flow with absolutely zero resistance, and it can actually float, levitate, above a magnet. And the kicker? It does all this without needing crazy cold temperatures or insane pressure. The possibilities here are just staggering. We're talking about power grids that don't lose any energy, computers that are mind-bogglingly fast, and yeah, those levitating trains you see in sci-fi movies, they could become a real, everyday thing.
And then, boom! July 2023. The announcement drops like a bombshell. A research team in South Korea comes out and says, "We did it." They claimed they'd created this exact material, this LK-99. They said it worked as a superconductor at normal room temperature, normal pressure. This wasn't just some small improvement, you know. This was a potential giant leap for mankind. But, and it's a big but, if it was real.
And at first, the evidence they put out looked really promising. I mean, it was tantalizing. The original team published their papers, the data showed what looked like almost zero resistance, and they even released a video. And in this video, you could see this tiny, dark gray piece of LK-99 that seemed to be levitating just a little bit over a magnet. It was pretty convincing stuff.
But here's the thing about science, right? Seeing isn't always believing. There's a famous saying, extraordinary claims require extraordinary evidence. And in the world of science, the absolute gold standard for evidence, it's replication.
Can other scientists in a totally different lab follow the exact same recipe and get the same world-changing result? That is the question. And that's where our story takes a turn. We're going to shift our focus from South Korea all the way to India to follow a team at the CSIR-National Physical Laboratory. They saw the claim, they got inspired, and they immediately jumped on the mission to try and verify.
Okay, so let's get into their mission. It was super clear and absolutely crucial. Their goal wasn't to go out and just debunk the claim. No, it was to test it rigorously. They had to become like scientific detectives. The plan was follow that recipe to the letter, make a brand new independent sample of LK-99, run all the big tests, and then, this is key, report what they found to the world, no matter what the answer was.
Now, as you can probably guess, making a material that could change the world isn't exactly a walk in the park. The process for creating LK-99, think of it like a really complex multi-day baking recipe, but with incredibly high temperatures and even higher stakes.
So, the original recipe from the Korean team had a few steps. First, you had to create ingredient A, which is called lanarkite. Then you had to make ingredient B, copper phosphide. Only after you have both of those can you combine them, seal them up, and cook them at a crazy 925 degrees Celsius. Let's break down exactly how the team in India tackled this.
All right, so first up, they had to make those precursor ingredients. They created lanarkite, and then they made copper phosphide. This involved heating them for 24 and 48 hours, respectively. It's a long process, and at every stage, they used this really cool technique called X-ray diffraction, or XRD. You can think of it like a molecular fingerprint scanner. It basically shoots X-rays at the material, and the pattern they make when they bounce off tells you its exact atomic structure. It was their way of checking, okay, did we actually make the right stuff?
So once they confirmed they had the right ingredients, they ground them up into a powder, mixed them together, and sealed them up tight in a quartz tube with all the air sucked out. Then came the final step, cooking it all at a blistering 925 degrees Celsius for another 10 hours. And after all that painstaking work, they finally had it, their very own sample of this mysterious compound.
And there you have it. This is the final product. All that work for these small, kind of dark polycrystalline pieces. This right here, this is the stuff that the entire global scientific community was buzzing about. The Indian team now had their sample, and it was ready for the ultimate test.
All right, section 4, the moment of truth. Does it float? You know, with the sample finally made, it was time for the million-dollar question. Before they hooked it up to any fancy machines, they went for that simple visual test, the one that had grabbed everyone's attention online.
And this is really the whole key right here. It's called the Meissner effect. See, a real superconductor doesn't just stick to a magnet. It does something totally different. It actively repels magnetic fields. It kicks them out, causing it to levitate, to float above the magnet. This isn't just regular magnetism. It's the absolute defining property, the smoking gun of a superconductor.
You can just feel the excitement in the lab's own words from their paper. They said, the very first test we did out of our curiosity was to check if a permanent magnet levitates over the obtained LK-99 sample. I mean, after all those days of cooking and preparing, this was the first thing they rushed to do. It's so simple, right? Does it float or not?
So the moment comes. They take a tiny piece of their brand new sample and they place it right on top of a powerful permanent magnet. You have to imagine, scientists all over the world were following this online almost in real time. Everyone was holding their breath. Was this it? Was this the moment we'd all remember? The one that kicked off a new age of technology?
And the result? Well, you can see it right here. The sample just sits there. It's idle, as the paper puts it. No levitation, no floating, no sign of that crucial Meissner effect at all. The big, dramatic visual test, it was a bust.
Okay, so the visual test failed. But the story doesn't just end there. The investigation had to continue. That floating test is a really good first indicator, sure, but to really know what's going on, you have to look deeper with much more sensitive equipment. You have to understand the material's fundamental properties.
So here's the deal. For a superconductor, the magnetic properties are everything. It needs to be what's called diamagnetic, which basically means it actively repels magnetic fields. But when the team in India tested their LK-99 sample, they found it was paramagnetic. That's the opposite. Instead of pushing the magnet away, it was actually weakly attracted to it. Totally not what you want to see in a superconductor.
So the conclusion from the CSIR-NPL lab was pretty clear, but also very cautious. Their sample, the one they made at 925 degrees Celsius, did not show any signs of being a superconductor at room temperature. They couldn't make it float. But, and this is important, they stressed that this is just one data point in a huge global investigation. They were already planning more studies, maybe with different cooking times or temperatures.
And you know what? This isn't a failure. Not at all. This is the scientific method in action, and it's actually beautiful to see. One group makes a huge claim, and almost overnight, labs all around the world jump in to try and verify it. It's a transparent process of checking each other's work, and that's how we find out what's real. So, is this the final answer, or just chapter 1? Well, the whole LK-99 saga eventually fizzled out. Lab after lab tried to replicate it, and they just couldn't get the same results. But that global chase, that incredible, fast-paced, collaborative effort to find the truth, that was definitely not a waste. It was an amazing testament to scientific curiosity and that relentless, passionate, worldwide hunt for the next huge breakthrough. And that quest, well, that continues.